got started, we pretty much had one main developer. He was offshore, he was in Bolivia, and he was writing code for us. So far, life's pretty good, right? You got one developer, collaboration, pretty easy. Right? Unless you have multiple personalities or something going on, collaboration's going to be easy because there's only one of you. So then you've got two developers, right? Still things are pretty good. In this case, we had two developers sitting right next to each other, and they were able to collaborate very easily. There was a problem, they knew about it. If there was new code, they knew about it. They could talk to each other. Everything was very clear. Everybody's always in sync, right? So then this happened. Now we've got two developers in the US and one or two developers in Bolivia. Suddenly the landscape has become very different for those developers. Collaboration becomes strained. You start to have people who are out of the loop. Maybe she is feeling really out of the loop and out of sync. She doesn't know what anybody else is working on, right? You start to get this dichotomy. And the more you spread, the worse it gets. So then developers, being developers, look for a technological solution. And they get a central repository. In this case, GitHub has worked really well for us. And they push their changes to that central repository, and they get shared back out. Right? So far, so good. And this is as far as a lot of companies get. And Git's a great tool, right? Git does a lot of the heavy lifting of making sure that my changes work with Matt's changes, and Matt's changes don't conflict with Fumiko's changes, right? Git helps with that. It's a great tool. But then your organization starts to pick up steam. Pretty soon, your developers around the world are producing a lot of code, and they all need to be tested. As things move forward, things that used to be simple now become complex. Right? You used to have a small code base, you were a one-page thing, and now you've got a bunch of pages, and there's a lot more that can fall down, a lot more that can break. And all these developers here, you see, they've each got their little features that they want tested and pushed out to live. So as a smart organization, you say, well, we need to bring in some expertise. We're going to bring in some QA resources, and now when things need to get tested, we're going to push them out through QA. QA, of course, quality assurance, right? They're going to assure, or ensure in this case, they're going to ensure that our quality is up to snuff and make sure that our code that's going live is great. This is a pretty common situation right here, right? You've got things pushing through, and they go to QA. QA says, yeah, that's great, gets checked off, and goes over to the approved column, right? Quality has improved. QA, their modus operandi is different than the developers. A developer, when they test their own code, they're looking for things that they know should work, right? They've got the wrong mindset for breaking the code, right? If the engineer who builds the car and plans the car is also the engineer who test drives the car, he may even subconsciously never get it over 30 miles per hour, right? Because he is looking for the things that he knows work to work. So here QA is helping. We've got developers pushing changes out, but we're starting to see a bit of a bottleneck. Everything's got to go through QA. And yeah, things have slowed down, and at first that feels really good because as an organization, you see the quality improve. You see that your website's actually working a lot better than it used to. You're getting fewer customer complaints. But then as things progress and your organization starts to accelerate, you realize that you've created a new problem. And that is QA, like it or not, has become your bottleneck. Unless you're going to go out and hire as many QA people as you have engineers, right, which is not a sustainable model, you're going to have a bottleneck at QA, because QA is only going to be testing one thing at one time. So here at DemoChimp, we ran into exactly this problem, where we had great QA. They were doing a phenomenal job, but organizing this communication, having this developer say, hey, I got this thing ready to test, and then having QA say, great, pass it over, I'll test it, no problem. Well, this developer up here is now log jammed, right? He can't get anything done or tested because he's waiting for this developer's code to be tested. So that's where we found ourselves, and we decided we needed to focus on QA. We got developers in the Philippines, India, Bolivia, Belarus, right? How do we keep the thing flowing for everybody? So we started to focus on QA. And one fine weekend, more out of necessity than out of like deep planning, we came up with a really simple solution to this problem that's worked really, really well for us. It's fast, it's been simple, and it's eliminated the QA bottleneck. And so that's what I wanted to share today. Step number one is automate the checkout of the code in a place where QA can test it. Take that out of the developer's hands. Take the responsibility off of the developer's shoulders to say, hey, my code, it's over here, you can go test it. I'm going to go check it out on server B, right? So you can test it. Go check it on server B. Take that off of their plate. Make it completely automatic. Another side effect of this that's really, really good is developers are no longer directly touching the box where things are being tested. When a developer is directly doing things to prepare it for QA, whether they like it or not, they may be doing things that aren't being codified, if you will, or aren't being canonized in the actual code that's going to your source control, your source repository. So here at DemoChimp, we now actually have 35 of these environments. And it's no harder to manage those 35 environments than it was to handle one. And if we need 70 this next weekend, we'll spin up 35 more. So step number 2, make the name of the repository very easy to remember and easy to communicate. Make sure it's clear. So when a developer says, hey, I've got this code out in Mexico, for example, we use MX and IT and different country codes just because it's fun and easy to remember, that QA and the developers have no confusion about where that code is and where it's ready to test. So they could say it's on the Italy branch, right? No confusion. On top of that, we've got a domain name that's exactly the same as the name of the repository, or in this case, the branch, the Git branch. This makes it really easy. The developer knows where the changes are because it's the same branch that they're working on. And QA knows which branch it's on because it's the same as the name of the domain they're hitting. So you're eliminating the confusion or the need for any extra thought or worry about where things are and how they should be tested. Step 2 of the automation of this is when you want to communicate out to GitHub, in our case it's GitHub, it could be any external repository, you only want to do that once. If all 35 of these environments are reaching out to GitHub to get their updates, you're really putting a strain on the server. Now to give you some idea, these 35 environments are running on one T2 micro instance. At Amazon, that's as small as it gets. That's about $12 a month for one instance running 35 of these environments. So you don't want all of them. You don't want to tax your server with having all of them reach out. You don't want to use the bandwidth, you don't want to use the CPU resources, and you haven't got the RAM. So you want to do it once here at the local master, and then have it reach out and pass it to each of those sub-environments. So here's your developer. Life has gotten a lot simpler now. They've got these different tasks or projects that they may be working on or looking at. So they make their changes locally. When they're ready to share their changes so that product can have a shot at it or QA can have a shot at it, they pick a branch. In our case, we've got a wiki, and there's a list of branches on the wiki. They put their name next to it, and they put the date, and now that branch belongs to them. They push their changes to the repository, and that's all they have to do. This is what developers are doing all day long. They're checking code out, they're making changes, and then they're committing it back to the repository. When they committed it and pushed it back to GitHub, instantly their code appears on that host. They haven't had to do anything extra. It just automatically appears there within seconds of when they pushed it up. In our case, part 3 of this is we also use a product called Slack. I don't know whether any of you have heard of Slack. It's kind of an up-and-coming communication medium. It's kind of a very fancy chat room where you can all work together and collaborate. Very good for disparate teams like ours is. Now Slack automatically it's got these APIs that you hook into. We, by the way, are still using the free version of Slack, so this does work on the free version. These APIs where when there's a change on the server, it pings it. And everyone, it's like they get an instant message almost, but it's grouped off into this one little chat room out of the way. So your developers don't even have to call each other or tell QA that they've got a change out. That process is also completely automatic. So in the case of our remote developers, right, they've pushed this change up and say it's on test HI. Right? They may be asleep when QA gets to it. But that communication doesn't have to slow things down, or that lack of communication, because it's already been pushed and QA knows what's going on. Once you've done it, you just repeat. Developer goes out, picks another branch, and pick up right where they left off. So this process inside the server is not very complex. It's literally a bash script about 15, 20 lines long. It reaches out to GitHub, makes an update. When it's got the update, it checks. It says, hey, did I get any changes? If it got changes down onto this local master, the only one that talks out to GitHub, it pushes them out to each of the local repos. Again, it's part of the same 10, 15 line script that does all the heavy lifting. But this process is extremely fast because it's all local at this point. The fourth and final part of this is each of these test environments needs to have its own database. Now that's going to get expensive if they literally have separate databases, but on Amazon, the smallest database size is like $35 a month. That's enough for a test environment. And on that one database, you create all of these logical databases. So each test environment has its own logical database. That's important because if a developer makes a change that touches the database, they can't be breaking everybody else's code. They each have to have their own database to make changes on. And that's it. So I want to know, are there any questions on my whirlwind tour of our QA success? Yeah.
How many QA engineers do you have?
We have one full-time. Actually, we have Rosie. I'm going to qualify that. So this is Rosie. Would you stand up? The developers love Rosie because she saves us from falling on our faces. Yes. Thank you. But Rosie also actually does other part-time writing here at DemoChimp. So she's full-time QA when she needs to be, and she's full-time writer when she needs to be. So she is full-time, part-time. And then we have Darian. Darian, you here? Darian's our up and coming. Someday he's going to be a brilliant engineer. So you met him here. If you want to get his autograph, get it before he leaves. But he's also helping us with QA.
Cool. How about your stack? What does it look like? I want to understand how you're keeping all the pieces in those environments. Is it a monolith? What is it?
So our stack is fairly monolithic. It's pretty much one big repository. We do have some sub-repos as well, but for the most part, those are not being updated. They're just external code that we didn't want to have to write ourselves. Okay. So we're looking at pretty much one big PHP app, and behind that is one MySQL database. There is an API and everything, but that also is rolled into the same code base. Okay. Yeah, so one of the things, and I didn't say this much during this, I meant to say this a lot, keep it simple. Right? Keep it simple. And our stack is simple. This process is literally a script that I paste and run. Right? Don't make things more complex than they have to be. Keep it as simple as you can. There's enough complexity in the business problems you're trying to solve. You don't need to add it in your coding practices or your QA practices. Any other questions? Okay. Oh, yeah, go ahead.
Do you see any limit to the scalability of the model?
No, not really. With this local environment being like it is, I mean, we could easily probably go to hundreds with the stack that we have now, and we're pushing, what, $60 a month, right? So scaling this model up to being thousands of this might be $150 a month. Right? So I don't see the scaling being a problem. I don't know any organization that would need that many test environments. So for us, one thing that I didn't really say either is you notice the different colors here. Imagine that 4 of these come from one developer and 6 come from another. That's what this is meant to portray. Is every developer can have multiple birds in flight. He doesn't have to wait for QA to come back on his current feature he's working on. He can move on to something else while he's waiting for QA to go in and test. So again, QA is no longer the bottleneck. Any other questions? Okay, great. Thanks, everybody.